Okay, so now what I'm going to do is I'm going to touch off on the outside of the part. I'm going to dial in probably about 50 thousandths. I'm going to take a shortcut, maybe a 3/8 of an inch long, so I can measure the diameter. And then I'm going to program the readout up here on the x-axis to the diameter that the tool is at, that I got from the micrometer off the part. I'm going to switch it to set. So it says set up here. I'm going to push the x-axis, and then I'm going to enter 1.9515. Yeah, we're going to say that's 1 inch, 951.5 thousandths. And I'm going to hit enter. Then now as I move the cross slide in and out, and my tool changes the diameter, it's going to track that on the screen. I'm going to be checking it as we go with either my calipers or a micrometer. I want to use this technology, but I want to keep my eye on it, and I'll also be paying attention to the dials themselves. But it is great to have a digital display, and I'm definitely going to use it on the z-axis. So I'm going to start the lathe back up, touch off on the face of the part, and then I'm going to zero the z. For the z, we don't enter any values, it's just 0 in this instance. Okay, so my diameter is set. I'm going to keep my eye on it, and my Z has been zeroed on the end of the part. Now I know the part's overall length is 1 inch and 5/16. I'm also going to part this part off from the stock, so I know my part off blade is an additional 1/8 of an inch. If I combine 1 inch and 5/16 and 1 inch and 1/8, I'm at 1 inch and 7/16. But I might as well give myself a little bit extra, so I'm going to actually move the cutter down, the turning tool down the part to 1.5 inches, 1.500. That's close enough. I'm going to turn on the lathe, and I'm going to make a groove or a mark, which is essentially a layout line. Check it with my ruler. It is 1.5 inches, so that looks good. Now I'm going to go ahead and take my cuts. I'm at 2 inch to start with. I'm going to 1 inch and 5/8. That's 3/8 of an inch total that I'm going to remove off the diameter, 0.375. And I'm going to take it in 4 passes. I'm going to take 3 passes of 100, and then the remaining value. Now the readout displays 1.904. I'm going to go ahead and throw a mic on it and see where we're at. like I said, I want to check to make sure all of my technology that I'm using is actually working. Readouts can skip. We're doing okay. I'm at 1.7, but I'm going to take one last reading before I pull the final pass, which will take me to my 1 5/8 diameter. All right, the sides look good, so I'm going to dial to 1.625. I'll grab some calipers so you can see the size. 1.625 was what we were aiming for. 1.625, 5. That's what we got. Okay. So now I'm going to go and turn down 1 inch back to 1.485, and then that'll allow that diameter to be 1.5 after the knurling makes the material grow. There's an inch back on the readout. There's my little line, so I know where to stop. And I could also blue this up and scribe it, but this is faster. So it looks good to me. Now, I'm not going to take this in one pass. That would be, it could be okay. I'm going to break it down into to 2 passes of relative even value. Alright, so that should read 1 inch, 485. .484, good enough, right? Okay. Alright, I've switched over to my grooving tool, and I've adjusted my RPMs. Now I could either line up this edge to my shoulder to the best of my ability, or I could touch off this edge, zero my readout's Z-axis, and then move over an inch and then put my groove in. I'll go ahead and do it that way. Z-axis has been zeroed. Moving the carriage over 1 inch. So my X diameter is zeroed out. The size is not given on the print, but if it was, it would be 1 3/8. I'm at 1 inch, 380. So we're happy with that. Now with this pinch type knurler, I want to open the wheels to a diameter that will almost allow me to completely cam over the top of the part. And you can do a lot of setup with the machine not running. Just with it in neutral and rotating the chuck by hand, you can get a lot of your knurling setup completely dialed in. So this right here, my knurling wheels, if I wanted, I could probably continue to crank in my cross slide, and I could probably cam the knurler over the top of the part. I'm going to slide it in between gears, and actually I'm going to blow off those chips. You definitely don't want to start knurling in with a dirty part with chips on it. That'd be bad. So I made contact. Now I can roll this by hand if I wanted. I usually just put the machine under power, but I wanted to show you. Okay, so everything's looking good. It's going to give me squares. I'm going to go ahead and actually just turn on the spindle around 100 RPMs. And I'm going to adjust my feed rate to 0.015 for knurling, 15,000ths of an inch. Now, I'm going to turn on the spindle, feed the knurler in. I'm going to stop it to assess my knurl progress, and then as soon as it's good, I'm going to immediately engage the feed and get the knurler moving down the part. I don't want to dwell in any one spot for longer than I need. and I'm basically getting a perfect knurl. So I've engaged the feed.